We will continue now speaking about power supplies in industrial applications, and we'll be taking you through all the portfolio elements that we offer to power industrial automation systems. And in addition, also we will show you how the digitalization trend have penetrated also even the power supply design and implementation. So you will get an idea of what are the innovations that we are doing in the power supplies and what to expect in the future as well. Let me start by showing you just an overview of the power supply family in Siemens, which we call SITOP, and the name SITOP comes from Siemens top reliability, top efficiency, and top integration. This is the name, and this is what the power supplies always stands for in Siemens, because of a very obvious reason is that the power supplies are the heart of the automation system. Nothing can work in any system without the power supply. So it only makes sense that the power supply, even though it's when compared to an automation system, a PLC or an HMI, it's a simple component, and it does not have that much of a cost when compared to those components. After all, it is the component that is powering everything. So within our portfolio, within the SITOP portfolio, we have what you see here is power supplies, advanced power supplies, standard power supplies, and basic power supplies that we will just probably one slide from each model. We will have a look what are the distinctive features. Now, in addition to that, we have power supplies for specific requirements. We will also mention it after that. Then we will come to the second part, which is not the power supplies, the add-ons to the power supplies. What are the electronic components that are added to the power supply to make it more reliable? Yeah, we will come to see we have different topics, start from the redundancy modules, selectivity to UPS modules. Let's start with the basic power supplies. The basic power supplies have actually three different models, and as we go on, you will see distinctive features between the basic range and the standard range and the advanced range. So for the basic power supplies, we have three models. First one is the SITOP Compact. SITOP Compact is specifically designed for space-saving applications. So the intention behind it was to use it in control boxes and distribution boxes, and this is suited a lot for the standby mode applications that the system is for a long time have no actual load, because that power supply has very low losses at no load, as you can see here. But all in all, it has a very nice feature of wide range input, and it accepts AC or DC input. So you don't really need to worry about what is the input that you are connecting. And this is considerably for the lower range, as you can see here. So we have two different power supplies giving you 24 volt or 12 volt, but still we are on the low current range of the output. So up to 4 amps we can have, that is maximum. So it is intended for small applications. But as you can see, it supports the wide range input, so you can connect AC or DC, but single phase AC, of course, and you do not have to worry about any switch or anything before you connect. It's automatic detection of the range. Being a basic power supply, the efficiency is not the best, so we can have up to 89%. Still good, but we will see better performance. And in terms of diagnostics, it does not have any remote diagnostic capabilities, so it gives you only visual diagnostics via an LED to indicate that the output voltage, the 24 volt, is okay. And a very interesting thing, it can operate, the standard product operates up to 70 degrees. And you can see all the available certifications. Most of the certifications are available for most of the power supplies. Moving to the next model, which is the logo power. For you who knows our logo logic modules, they are small controllers. This is in the design of logo. So this is a power supply which fits into distribution boards. Again, it's part of the basic power supply family, but it still has the wide range input capability, AC or DC. But again, it is for small applications. So we are limited to the 4 amp output, actually, but we have different variants of output. So we have, in addition to the 24 volt and 12 volt possibilities, we do have some power supplies with output 5 volt and 15 volt as well for other applications. And efficiency up to 90%. And up to now, still, we don't have any remote diagnostics capability. So it is only visual diagnostics via an LED on the power supply to indicate that the voltage is okay. And it operates again up to 70 degrees. Now, the third model within the basic power supply family is SITOP lite. And the SITOP lite, we can say that it's a cost-effective option, just a very basic power supply with just the necessary functionalities. So without any options, let's say. And the thing here is that this will give you power supply output ratings up to 20 amps. So we can have from 2.5 up to 20 amps with 5, 10, 20. But as you can see here, for example, in order to switch between the ranges, you have to do it manually. So it supports the input, AC input ranges and DC input ranges, but we have to switch manually the input range before connecting the power supply. Again, we have the efficiency around 90–92%, and signaling still it's via just visual LED to indicate that the 24 volt is okay. And you can see here that on the temperature, on the operating temperature side, it operates up to 60 degrees, unlike the other power supplies, and it starts derating after 45 degrees. Since we have seen this derating, let me explain what does it mean. So the power supply, for example, let's say that we have the 10 amp power supply. The power supply itself, it can operate up to 60 degrees, but not for the full 10 amps. So up to 45 degrees, you can still have 10 amp output of this power supply. And once the temperature is starting to rise, for each degree, there is a drop in the current rating that you can use. So from 45 to 60 degrees, you can expect that the rated current will drop by 20 or 25%. So maybe you can have only 8 amps out of it by the time you get at 60 degrees. So this is the derating concept. All right, now let's jump to the standard power supplies. Standard power supplies, we had the SITOP Smart up until last year, when we had the new innovation in power supplies, which is the power supply 6200. We will come to that power supply family in more details, because this is what we see that is going to be the future of the power supplies. Let me explain about the SITOP Smart. This is our standard power supply. So this covers almost all the possible current ratings, and also it covers the single phase, 3-phase connections from the AC supply as well. And it has relatively high performance with efficiency up to 91–92%. And it covers the range from 2.5 amps up to 40 amps. So it covers almost all the possible ratings that you would wish for. And now you can see that why this is considered a standard power supply. So it's a special compared to the basic ones, because more or less the overload response. So here you can see that in the power supplies and the basic power supplies, you can go up to the rated current, and that's it. At any time that the load exceeds the rated current, you are in the overload region of the power supply. But here, for example, you can see that this extra power feature enables you to withdraw almost 150% of the rated current for 5 seconds of each minute. So if at any time you have a 10 amp power supply and the load have become 11 or 12 or 13 amps, as long as it's for a short period up to 5 seconds and not frequent, so it's coming maybe every minute or more than that, then this is okay for this power supply. And another interesting nice feature is, as long as you operate below 45 degrees, then this power supply can provide you with a constant 120%, which means that a 10 amp power supply operate. Of course, you have to make sure that the temperature where the power supply is operating does not go above 45 degrees, but in that case, you can consider that you have a 12 amp power supply constantly. Another point here is the signaling. So in addition to the LED, we have a signaling contact, which typically connected as a digital input to an automation system or PLC to have an alarm triggering that the power supply 24 volt is not okay. So this enables fast troubleshooting and immediate diagnostics. So this say trigger, of course, can be displayed on an HMI or even transferred into a SCADA system. So there would be a quick reaction time to fix the problem when it happens. And again, of course, we are back to 70 degrees. So you will see that only that SITOP Lite model has the 60 degrees operating temperature. Now, jumping to the advanced power supplies, we have two models. One is the SITOP Modular, and as you can see here, we have, in addition to this single phase and 3-phase, we do have this universal 1-2 phase power supply. This is a very useful power supply when you want to have a stock of power supplies, and these power supplies, you can use them for any type of system. So whether the supply is single phase or 3-phase, you can use this one and get the rated current out of it. The nice here in the SITOP Modular is that it has a compact rugged metal enclosure, and it has again the ultra wide range feature by automatic detection from the line supply. So this is an interesting feature again, and it has it covers also all the possible ranges, almost from the 5 amp up to 40 amps power supplies. And again, what is special here, that efficiency is even higher, so up to 94% of efficiency, and the overload response is again has some special advantage here. So besides the extra power feature, which we talked about before, which exists also on the standard power supplies, it has what we call a power boost. So this power boost actually will make your power supply capable of providing 300% of the rated current for a very short time, up to 25 milliseconds. This is very useful for this specific reason. So to trigger protective equipment when a short circuit happens. So in short circuits, you expect the current to really go high, and then this will enable the power supply at least to react within that time. And of course, it has beside the LED, it has signaling contact for the voltage. Okay. Now the second model, which is part of the advanced power supplies, is what we call a power supply system, the PSU8600. And here we touch base with digitalization a little bit. So this power supply system, it is not a single component. It's a combination of different components together. And the main part is this power supply. So this is what actually accepts the AC line and converts the power into 24 volt. And we have 3-phase and single-phase versions out of it. And it always comes with 2 Ethernet ports, which they support Profinet and OPCUA. And they support also the Profi energy profile over Profinet. And these modules usually have control channels. So you convert this into a 24 volt DC, and then you have your outputs control. So you can say that this is a compensation of different power supplies. So instead of having 5 or 10 power supplies supplying different subsystems, you can have one power supply system centralized supplying all the subsystems. And as we can see, this can have up to 4 output channels, which you can control how much current you want out of it. You can also expand it to have more channels. And the fact here is that you can have up to 36 channels by using this CNX modules, which are expansion modules. And the fact is that there is no wiring effort. You see this plastic connector over here. So the connections are done via this connection, and there is no wiring required at all. And in addition to these expansion modules, we can have some buffer components to back up the power in case that the AC line is interrupted. Again, everything is connected via the DC link here, so there is no wiring in between the components. And because of this interface, you have the capability of centralized configuration, monitoring, and control of the individual output channels. And this is, as you can see here, we have function blocks for our PLCs. We have faceplates for our SCADA systems and HMIs, ready-made, and we have libraries also for our DCS7 system as well, which are ready for you to use. So you can visualize actually the status of all the output channels. What is the consumed current? What is the output voltage? If any error happens, directly you get the alarm and you get the indication that this channel in particular has tripped. And of course, it provides the isolation for all the channels. So if one channel trips, then only that channel is affected and not the entire power supply system. So it has, as we said, different expansion modules. We will see in the next slide. Again, it has the extra power capability, just like we mentioned before, high efficiency, and support of the communication protocols. This is the whole components of the PSU8600. So these are the different power supply modules available. So you can have it with overall 20 or 40 amps, and either you have it with one output or with different outputs. So this is 4 outputs for these 2 models. This is only 1 output. And this one, any one of them, you can always expand it by one of these, of course, or more. This is what you see here is the maximum configuration of the system. So 1 power supply, and you can have up to 4 expansion modules and up to 1 buffering module. And you can see here the batteries which are connected to this UPS module to back up the system in case the mains supply has failed. All right. So now let's jump to the most important topic of this presentation, which is the new power supply family, the PSU6200, which has been released actually beginning of 2019, and now this is going to be our, from now on, this is going to be our standard power supply. So you will expect that in the upcoming years, more and more power supplies variations will come in the design of the PSU6200. And the intention is to have a comprehensive product range in the way that it will support all the different output voltages, single phase, 3-phase, small current applications and high current applications. And as well, we also have the add-on modules such as the redundancy modules and selectivity modules also in the design of the PSU6200, as we will see next. So up to now, so now we have the single phase, and we have also the 3-phase will be coming soon. And one nice feature is that it has a wide range AC or DC input, as you can see here. So there, with automatic detection of the line supply, so there is no manual switch to do or to take care of. And we do have the 12-volt and 24-volt variants available, starting from, as you can see, 1.3 amps for small applications up to 20 amps for 24 volt. Now, what are the main features of this new power supply family? You will see that there is a lot of nice, interesting things. First thing is the diagnostic monitor. So now, instead of one LED that indicates that 24-volt DC output's okay, we have additional LEDs that can show you visually the utilization of the power supply. So how much is the output current? Which is quite interesting. Without putting an emitter in your circuit, you can just look at the power supply and know how much current is being consumed by the loads. Another interesting feature is the diagnostic interface. So now, you remember we said that we have signaling contact in the power supplies before, which will indicate to a PLC that the power supply output is okay or not. Now, for this power supply, we have further improved this. So we connect this signaling contact into a digital input of a PLC, but it is not just a digital input. We actually transmit information over this digital input, and we have a pre-made function blocks to be used with the PLCs in order to read information from the power supply itself. And these information includes how much current I'm supplying, what is the voltage, temperature, and we have several informations that we can read over this diagnostic interface. Bush-in terminals in the design for the whole family now, we don't have any variant with screw terminals. So always push-in. So without using any tools, we can do complete wiring, and thus we save the time. Compared to the classical power supplies, now we have narrow width. I mean, if you compare the same ratings, then this is significantly having a narrower width. And as we said, it's going to be an integrated family. So we will have one big family of power supplies, same design, same concept, same features that covers all the possible combinations that we need. And this is actually quite interesting because, I mean, we consider it as a standard power supply, but I mean, in the standard range, but the efficiency is relatively high. So we have up to 95% efficiency. And also a nice feature in the case of overload, the power supply is not switched off. It can supply constant current. We call it a constant current behavior in case of overload, and the voltage starts to drop up to 15 volts before it is switched off. All right, so let's see a closer look on the diagnostics features. So you see here, these are the LEDs that I'm talking about. And just to highlight that these diagnostic features, what you see here, all the features for the entire family, but diagnostic features, the LEDs and the diagnostic interface are available for the 10 amp power supplies and higher. So for this LED, let's start with LEDs. What does it mean? So the DC OK LED is still there. You can see it here on the top. And if it is, of course, green, then yeah, everything is okay. If it's flashing, then the output voltage is not okay. It's out of range. Now, the other LEDs, which you can see here, these are indication of the output current. And you can see if one of them is green, then this means that you are utilizing the power supply below 30% of its rated current. So if it's a 10 amp power supply, then you are from 0 up to 30%, so up to 3 amps. Actually, up to 3.3 amps. If you have 2 green, then you are consuming between 30 to 60%. So you are maybe 3.3 up to 6.6. If the 3 LEDs are green, then you are utilizing from 60 to 90%, which means that you are almost utilizing the full limit. And if the utilization is higher than 90%, so above 9 amps, you will get 4 LEDs, but in the color yellow, which is not an error, it's just a warning that this is very close to the limit, and you need at least to check. If this is okay, then it's okay, but maybe this is an indication that something is wrong. Now, if we have this combination, which is 1 yellow, it means that the operating hours of the power supply has exceeded 90% of the service life. And this is actually a nice feature which is built in this power supply based on our testing data. There is a built-in service life in hours saved in the power supply, and there is an operating hours counter inside the power supply. So this is continuously compared to each other, and if the value gets higher than 90%, then you have this indication. This is not, again, this is maybe you get this yellow LED and the power supply works for a long period after that, but this is at least an indication that, yeah, please take your measure. Maybe get a spare, keep it ready. Yeah. So it's easier for that. And you can see here on the right what are the say possible scenarios that we might face. So if the power supply, for example, is overloaded, then maybe that actually the power supply is supplying a machine which is actually requires this load. So maybe, I mean, having this, yeah, will get you thinking that, okay, what's the issue? Do I have really high load? So if I have a high load, then I might think, okay, maybe I get a bigger power supply, or maybe I use a second power supply, identical one, to supply and split the load between the power supplies. But there is also the scenario that, yeah, the load shouldn't be too high and there is something wrong. Maybe something is stuck. Yeah. So this will allow you to at least have an idea of what is the issue and you correct it. Okay, so regarding the other diagnostic feature, which is the diagnostic contact, again, as I mentioned, we do have a ready-made function block with faceplates for HMIs and SCADA systems to visualize and have all the information read from the power supply. It requires only connection to a digital input. And by the way, the function blocks are written in, they are open source and written in SCL language, so anybody can have a look and maybe compile them into a function block in any even third-party system. So this can be also used. As you can see, we have some kind of user information. What is the let's say device type and so on. So this is the information tab. What is the state of the operating hours, temperature, and there is an import error, and this is exact representation of the LEDs on the power supply itself, and there is a couple of dip switches on the power supply as well, so for different functionalities, but this is a representation of them as well. And the output here, you can see what is the output current, what is the output voltage, and you can also log these values and use them to visualize, for example, what is the power supply consumption throughout the day or throughout the week, or comparing maybe units to each other using the same power supply in order to have more transparency on your system. So very interesting. And again, this is not, this is just setting the base for the new standard power supplies. This, if you have, for those who tried this power supply or have acquired it before, it has no price difference than the standard power supplies, the other standard power supplies that we have in our portfolio. It's more or less the same. All right, so this finishes the power supply part. Let's speak about the other requirements for the power supplies. I think maybe most of you is, familiar with this. This is the power supply in the design of our PLCs. So our S7300, 1200, 1500, and also the our I/O systems. So ET200 SP, MP, and ET200 Pro. So these fall under the standard power supplies, but they are fit into the enclosure of our automation systems to have a uniform system. And we have some other power supplies for special requirements. It's good to highlight the DC-DC power supplies. So these are power supplies that we use to convert, for example, 24 to 12 or 48 to 24. So we have all the possible combinations. Or if you are trying to stabilize a 24-volt, maybe power supply coming from a solar panel, for example, or a battery-powered application. We have some outdoor power supplies to be mounted directly outside. We have some wall-mounted direct power supplies as well. And the last part of the presentation is the add-ons to the power supplies. And the add-ons to the power supplies, of course, they provide functionality. So the power supply gives me 24-volt DC, but what options do I have to make my 24-volt DC more available? And we have three kind of improvements, let's say. So protection against the failure of the power supply itself, so hardware failure, which we fix it by, or which we, of course, overcome that by using redundancy modules. Then the issue of overload or short circuits on the power supply, which will disturb the whole load on the power supply. And we have the selectivity modules in order to do that properly. And then we have the AC supply failure, which we compensate that by having a DC UPS added to our power supply. And in this graph here, we see the redundancy module. Of course, we can have one of them, you can have two of them, you can have all three. So you can have only this redundancy module, you can have the selectivity module as well, and you can see in this example, we have all three of them, how they work together. So the first thing is the redundancy module, then the output of the redundancy module is coupled with the output of a battery into the DC UPS, and then this is what is, before it's going to the loads, it's being distributed by the selectivity modules. So what is the idea behind each of them? The redundancy modules, simplest one. So as you can see here, it connects two power supplies and it couples them to one load. So if one power supply fails, there is no interruption to the load. And we used to have two variants, one with 40 amps output, suitable for coupling two 20 amps power supplies, or we have the 10 amp version, which is suitable to couple two 5 amp power supplies. And always you will find that the redundancy modules, because they are coupling two power supplies, there is a signaling contact. So this is very important in order to wire the signaling contact as a digital input to a PLC in an automation system. And of course, if you don't do that, then maybe one power supply fails and you are not aware of that, then this is not the idea. The idea is that there will be no interruption, but at the same time, we have to know that one power supply has failed, so the technician can go and fix the problem. Then you have your redundant system again running. So this is very important. Otherwise, one power supply will fail and you will be working on a single mode. Then maybe if the other power supply fails, then you are the system dies. And as we said before, when we talked about the PSU6200, that we are going to have one integrated family as much as possible into the PSU6200, which includes also redundancy modules. So now we have these new redundancy modules, which we call them the Red 1200. And they have a couple of nice features. So they are a lot of nice things is that they have a new variant actually. So they add a new variant, which is the 20 amp. So this is suitable for decoupling of two 10 amp power supplies. So this variant we did not have before. Again, as everything in the PSU6200, the narrow width and push-in terminals all the time. And this is also interesting. We use it when we want to do serial connection of power supplies. So if you want to have a 48-volt power supply out of two 24-volt power supplies, then in order to provide the necessary protection to the power supplies, we use this redundancy module also to couple the power supplies in order to provide a 48-volt power supply. One more thing, which is relatively new, the range of outputs or range of voltage that it can handle, it's relatively wide. So even if your system is 12 or 15 or 48 volt or 36 volt, which are sometimes common in some applications, this power supply, this redundancy module can do the coupling. So it's not only for 24 volt. All right. Now, the second topic here is the selectivity modules. And I know this is sometimes confusing. What is selectivity module? The selectivity module simply, it is the safe way of distributing the 24-volt DC. Basically, what we see in most systems that we use circuit breakers in order to distribute the output of the 24-volt power supply. and separated into load groups, which is fine for, let's say categorizing the loads into load groups, but actually it does not provide the perfect trip functionality for a DC power supply. This selectivity module, of course, have the very fast behavior in case of an overload. So it provides what we call electronic tripping, not electrical tripping. And it provides also sequential channel switching to reduce the inrush current on the power supply output as well. And it comes in 4 different channels. This is the classical one actually, and we have a new one also in the PSU6200 design. So as you can see here, the power supply supplies this selectivity module, and then it has 4 different channels supplying 4 different loads, as you can see here. And the interesting thing here is that these, usually here, these electronics, which are usually PLC or an HMI or maybe a switch, these are sensitive to voltage variations. And these loads, if there is an overcurrent in this motor or maybe a short circuit over here in this loop, then you will have a let's say short overcurrent, which means there will be a dip in the voltage, and in most scenarios this will lead to a restart. Of course, eventually this line will trip, but it will have already caused a restart of a PLC or an HMI, and this means in most applications a shutdown. So it's quite interesting to have this product. It has the channels, of course we can adapt it individually. What is the tripping current of each channel? There is LED to indicate the status of each channel, and there is a button also if you want to manually switch off or switch on the channel. And also very nice interesting features that it has a diagnostic interface similar to what we have on the PSU6200. So we connect it to a digital input, and we have a remote. There is a ready-made function block and faceplates to also visualize and operate this device. And as I said, we have them now in the design of the 6200. So these are the new devices, and now they are available with up to 8 channels. So in addition to the version of 4 channels, we have up to 8 channels as well. Okay, so now I believe the last topic for today's session, which is the UPS, DC UPS. Now, as we know, now more and more the requirement is coming for installations in remote areas, and the reliability also of the system needs to be enhanced. So it's always important to have your automation system, and of course we always say automation systems because this is always what we are trying to keep alive. But it can be any 24-volt load that we are trying to keep it running in times of failure of the voltage supply. We have several options actually in this area of, let's say, buffering the line supply. Starting from the buffer module, the buffer module is actually not an actual UPS. it does provide buffering up to seconds, which is usually used to overcome any problems with the grid connectivity. So if from the supply, from the utility, the quality of the network is not that good, then maybe a buffer module is necessary, not to have the equipment fail every now and then because of the poor quality of the grid. Then for actual backup, we have backup either using capacitors, which is what the UPS 500 family does, or backup using batteries. Now, using the capacitors, of course, we cannot back up through long times. We can have up to minutes maximum. And usually this is used in combination with the requirement that you need to do a safe shutdown of your application. So this is also not really practical if you want to actually run your system if the power fails, but this is actually more of I want to safely shut down my system if the power fails before I go blind. This can include taking certain actions in the PLC, or even stopping an HMI application and safe shutdown of a PC, for example, before the power just goes out. And then it goes to an undefined state. Of course, it is, I mean, why we don't do that with the batteries? It has the advantage that the capacitors has a higher operating temperature and they are completely maintenance free. So that's why, yeah, they are a good option. But if you actually need to continue running your application, if the line supply goes out, then here we come to backup with batteries, which is generally done by the UPS 1600. Or if you are already using the 8600, we do have, as I mentioned, a UPS and battery modules suitable for the 8600 power supply system. But in general, for all the power supplies that we have talked about, we can back up those power supplies using this UPS 1600. Now, the UPS 1600 in general consists of two parts. The UPS module, which you can see here, and the battery, or the batteries, because we can connect more than one, which is this one here, for example. And the UPS module, you always acting as a coordinator between the battery and the power supply, and all the loads which are to be buffered are connected to the output of this UPS module. This is here you see in a more clear picture. And what are the distinctive features of this UPS 1600? Again, in terms of connectivity, we do have variants, so we don't, it's not the only option, so we do have variants with either USB connection or also Ethernet connection that supports Profinet and OBCUA as well. And it is completely integrated into TIA portal, which means that you can completely engineer it inside TIA portal. It has an integrated web server as well over the Ethernet port. So all the parameters, all the parameters and configurations can be done from there as well. And it has an interesting feature regarding the battery connection. So in addition to the electrical connection between the battery and the UPS module, we do have an intelligent battery management kind of technique to do optimal charging of the battery. We do that via the energy storage link. So there is another 2 wires between the battery and the UPS module with certain communication that allows this optimal charging to happen. We do have, in addition to the lead acid batteries, we do have lithium iron phosphate batteries for long lifetime in high temperatures as well. And similar to the power supplies, we have the high dynamic overload capacity, just similar to the modular SITOP modular power supply, which means the power boost and so on. So what variants we have? We have in the UPS module either 10 amp, 20 or 40 amps, and this is what we were talking about. So the power boost and the extra power features, which are similar to the modular power supply. The interfaces you can have, so either of these 3 variants can be without any interface, so only digital inputs and outputs. So we can have some diagnostics over these terminals, or it can be with USB or Ethernet. And as you can see here, we can back up to hours of operation with this system. Yeah, and everything, all the data, capacity of the battery, parameters, everything is available over the Ethernet or the USB port. And of course, by having the OBCUA server functionality, you can have any third-party application also communicating fully to this UPS module. Web server, as we mentioned, and we do have a software called SITOP Manager. We use it for commissioning of this UPS module. It's a free software, but it allows a visual configuration of the UPS module. And just like any other device that has any diagnostic interface, we do have ready-made function blocks and ready-made faceplates for HMIs and SCADA systems and our DCS system in order to facilitate the visualization and operation of our devices. With regard to the batteries, we have lead acid batteries from 1.2 up to 12 ampere hour of capacity, and we actually have the steps inside. So we have 1.2, we have 3, we have 2.5, we have 5 ampere hour, we have 7, we have 12. And with each UPS module, we can use up to 6 batteries of any kind. So within this range, so everything is lead acid except for the 2.5 ampere hour battery. So this is pure lead, and this is specifically designed to operate in a 60 degrees environment. So usually lead acid up to 50 degrees, no more than that. In addition to this, the 5 ampere hour version is lithium iron phosphate battery, which operates up to 50 degrees, but it still lives for a really long time, even at higher temperatures. And you can see, according to the table here, that the lead acid batteries that we have, based on the temperature, so if it is, usually you are between 20 and 30 if it is a regular installation inside a air-conditioned area. But if you are, and just a point to highlight here that when we say temperature, this is not the maximum temperature. So I know temperature might get maybe to 30 or 40, but this is the average temperature over the year. So even if you are in an outdoor panel installation and the temperature might get to 50 degrees, then yeah, the battery will not live half a year, not really, because you have winter and summer, and you have day and you have night. So the average temperature is actually what we are looking for here, which is usually, for example, 40, then maybe it will live for a year. But you can see that the pure lead can operate up to 60 degrees, and it relatively lives more. But even the lithium iron phosphate, which is the best here, that it lives for really, really long time without the need of replacement. All right, so here is an example of the integration, as we said, over Profinet of the UPS 1600 inside TIA portal. And this is a view of how the ready-made faceplate looks like inside a touch panel. So again, this is all ready-made, free of charge, available on our support website to download. And here, for example, for PCS7, our DCS, there is also a ready-made diagnostics graphics that are integrated into the PCS7 system, so you don't have to waste any time creating such a diagnostic graphics. And as we mentioned, because of OPC-UA support, you can have any third-party OPC-UA client having full access to all the parameters and functions to the UPS, changing parameters and reading all the possible measurements from the device.